Hey everybody, welcome to another Unity game development video, and today I'll be going over one of the new attacks available to the player in my Unity 3D character platformer, Brainine, and I'll be showing off that ability now in the play mode. Let me just switch to the max view, and I have incorporated some aspects of the VFX Graph. With this one, it's a little bit flamboyant, a little garish, a little over the top. Just keep in mind that it will be tweaked in the future, but if I press the right mouse button, you'll see that there is an effect. And it's like a pulse of energy that shoots out in every direction, kind of an AOE telekinetic blast. And the cool part about it is it's not just for show. If I go up to these blocks here and I use it, it'll blast the objects away. And it's a lot more interesting and a lot more complicated than it looks. So if I go back into the game and I go up to these blocks again, but I don't go all the way up to it, if I go over here, it's going to do a lot less pushing at a distance. And then if I go up to it, it's going to blast it away. And that is being handled by an animation curve, which is very interesting. And so since it is handled by an animation curve and we get these values from the distance of the objects, we can actually fine tune this to perform exactly any way we want it to. So if I go into power telekinesis, so if we go in here and we go down to where the push script is actually happening, the push function, we can see that we have a sphere cast going on here. And basically we're setting the position in which the sphere cast will shoot out. The radius of the sphere cast is set to 0. And then we're setting the VFX positions to those positions too. And I'll get to this list in a second. But essentially, over time, we are increasing the sizes of the sphere cast because it's just using that radius right there. We're lerping that. And we will essentially increase the size of that sphere cast, and as it touches objects, it'll detect the distance and determine the power that way. And right down here is where that power is actually calculated. So, this seems like a lot of functions and a lot of things all shoved together, but I'll explain it. First thing we can point out, we'll start at the middle since it's kind of all encapsulated. Vector 3.distance. So we're getting the distance of the player to the object that we're hitting. Okay, simple enough. We're clamping that value between 0 and the max radius. And the reason we're doing that is we don't want to get something slightly higher than whatever the max radius of the effect is. So we're just getting the distance, and we're getting generally the distance with no little bit of excess at the end. We're clamping that, and then we are dividing it by the max radius. And essentially what that does is it gives us, instead of a value between 0 and the max radius, it gives us a value of 0 to 1. So we're still getting that value that we're calculating right here. It's just being kind of recontextualized into a 0 to 1 value. So it's either the 0 or the maximum. So we have that value between 0 and 1. And that's very convenient for us because we are going to be evaluating along a animation curve. An animation curve generally, unless you're kind of using it in a weird way, it usually goes from 0 to 1. There isn't really a reason to go beyond these values if you know what you're doing and you're kind of properly using the values in the functions. Because any kind of y-axis value, if I bring it up here in the Unity editor, if I go to the character and we go to this animation curve, anything in the y value, there's no point in going above 1 because generally what we're doing is we're using this kind of to factor in other values. So if we brought it up to 1.5, that wouldn't really help us anyway because that's generally just a scale going up here between 0 and 1. So that wouldn't really help because we would just normally increase the multipliers that are using these values from the graph. So let's say that the closest you could be to the character when you're using the power 0. So at 0 on the x-axis, it is going to use the magnitude of 1. So if you're as close to the character as you can, it's going to use the maximum value. And it's going to do that for a little bit, up to about 0.1 or 0.2, and then it's going to start dropping off. So if we're halfway between, if the distance of the target is halfway between the character and the max radius of that sphere cast, then we will be at 0.5, and that'll bring us to around here. If we're as far as we possibly can be, we have something right here, which is another point, and that gives you a 0.01 value. So we're getting the values along this, evaluating along this animation curve, and then we are multiplying that by the push multiplier. So if we're as close as possible, this value is 1, so it's going to give 1 times 50, so 50 push value, or 50 units of force onto the object. If we are halfway the distance between the character and the max radius, then we end up around here. If I just add a key, we can see that is value of 0.8. So it'll be 50 times 0.8, which I don't know what that is. It's like 40 something, I think. So you can see how it's working. If we're all the way down here, if you're as far from the characters you can be while still receiving an effect, it'll be 0.1. So 1/100th. So what is that? 0.05? No. 0.50. So 0.5. You'd be receiving 0.5 units of force on the object. I hope that was simple enough to understand. I think it's pretty interesting. I think this is a really cool and interesting way to kind of fine-tune values in a force like this, and hopefully you find it as interesting, or you find it useful and you can use it in your project. Now if I go back into the code, there's a few more things we can look at. The push function is actually a coroutine. So we initialize the position of the effect. So we have this block here with this dual while block of code. So it says while time elapsed is less than push duration. So time elapsed is being added onto by time.delta time. So the push duration is a float value that is public in the inspector, and we can actually edit that. So this value will increase over time, and once it reaches this value, it'll stop doing the sphere cast. As that is happening, we are lerping the radius value between 0 and the max radius. And we could do that. We could generally just add a value onto that over time, but it's safer to lerp it here because then we can do the time elapsed divided by the duration and get specifically the correct time on there. So if I go into the inspector here and I increase the max radius of this effect, let's change it to like 50, it will still take that same amount of time to do the effect, but it'll be over a much larger area. So that's pretty cool. So we can fine tune the radius and the duration. So if I go in here and I change the duration of the, I keep wanting to say spell. So if I say spell during this video, you'll probably understand. So if I go in here, I can change the push duration to much longer. I'll change it to 5 seconds. And then I can just do a really large spell over 5 seconds. And the VFX graph is going fucking insane. Wow, that is a lot of particles. I wasn't expecting that. there's a lot of particles and a lot of HDR color effects. And I realized right before I did that, I said spell again. Fuck me. Okay, let's go back. Let's reset those values. That should be good. Cool. So, and then we'll go back into the code and look at it. So while that effect is happening, we are setting the lifetime of each of the particles to the time elapsed value. And that's just a quick and dirty way of making it so that the particles that are being instantiated near the center of the radius live a lot shorter than the particles that are near the outside of the radius. So those particles disappear quickly, and then the particles near the edge of the radius disappear after a longer period of time. And that just makes it look more like a fancy kind of effect. If we go down here, more VFX stuff. I won't cover that right now. Not super important. This is pretty much just handling making the effect fit the same radius as the what's it called? The power or the ability or the spell. So we are actually going to do the sphere cast now. We're grabbing the hits from that, which are just physics like raycast hits. So if we cycle through those hits, if the hits do not have the tag of player, so we're not going to hit ourselves, and those objects do have a rigid body, the rigid body does not equal null, and this hit objects list doesn't contain the object. So we have a list right here, list game objects hit objects equals new list. So that's an open list with no particular size, because we don't need to set the size of a list just for arrays. And we can actually, every time it hits something, we're going to determine that power that I just spoke of. We're going to add the power onto the characters, so we're adding that force onto the rigid body of the objects that we're hitting, and then we are adding that object to a list. And the reason we're adding it to a list is we don't want that force to be applied to the object more than once. So if I didn't do this, it would be constantly applying that force every single time the spherecast detected that object, and that's not something we want. So it adds it to that list, and then it checks it as the sphere is expanding. Every time it hits that same object, it's going to say, oh, that object's already in the list, don't add another force to it. And then the cool part is this list is actually being instantiated within the push that we make. So when we shoot out the whole like AOE attack, the list is created, the list is populated, then utilized, and then the list is destroyed. So that's good. I don't know if the list is destroyed. I'm not super into how information science and all that stuff works with coding, so it might actually be populating it with garbage. I'll have to look into that later. We might have to clean that up, but for now it works perfectly fine. And then we push the object, we wait for all of this to happen, so we're returning null, we're yielding to that as well, and then all those values are reset. So we get a really nice effect. I think it's pretty cool. Just pushing these objects and determining the power based on how far away they are from the character. I think it's really nice. So I could jump into the effect here on the VFX graph. And then what I'm going to do is I'm going to push all this stuff over. Kind of ignore this for now. This is going to determine kind of the directional vector from the character to the object. So we can actually add force onto the particles and kind of make them move in the direction out away from the character, kind of at an angle. It's not super important. Just ignore these. So everything else is happening. If you don't know how VFX Graph works, go look into it. I'm not going to explain how everything works in this, but I'm just going to explain these specific variables that are being utilized by the code. So the radius, it's actually grabbing that value from the code. So if we go back in there and we look at the radius equals 0. Where is it? So push VFX.set float radius to radius. So we're grabbing the radius value from here and we're using it in the VFX graph, which is pretty cool. I'm getting a smaller portion of that radius because if I have it a 1-to-1 value, the particles are kind of slow or they're kind of floaty, so it looks like that the force is being enacted on those rigid bodies before the VFX particles make it to the object. So that's looks less impactful if I do the full value. So I just make it move a little bit slower. Not a little bit slower, but the max radius is actually smaller. So the actual shock wave, kind of the actual detection of the object and forces that are being added onto it are moving a little bit faster than the VFX that's following it is. Here's that kind of lifetime variable that I was talking about, where the particles near the middle of the effect die off a lot quicker than particles near the edge of the effect, creating kind of a like the particles are whooshing out from the middle like a draft. So that's pretty interesting. And that's about it. There's a cool kind of wispy turbulence at the end. That's the kind of when they turn blue at the end and fly in every direction. That's what happens at the end there. And I think that's pretty cool. So, that's a lot more fun than just the rigid body character controller I was showing off last time I was doing the video. But I think this is pretty sweet. And hopefully you liked it, or hopefully you gained some kind of information from this video that you can use in your game. And I hope I covered everything, but thank you for watching, and I will see you in the next video. Have a nice day.